Thank you very much. So, you don't need me to tell you that our in-tray as a civilization, if you like, is daunting. We need to achieve progress on some of the biggest challenges of our time. Think about geopolitical conflict, think about population migration, perhaps inequality, and of course, the biggest challenge of our time, climate change and the path to net zero. And I know some of you in this room are directly involved in tackling, in our response to climate change, things like planning climate mitigation strategies, fighting habitat loss, increasing biodiversity. Magic, thank you very much. Now, it seems to me that to solve some of the biggest challenges of our time, we need to better see the world as a single ecosystem. And I think we are all here today in this room at an ESRI conference because we know that it is in fact geography, the science of the world around us, if you like, that can provide the framework and the language to describe this ecosystem. We know that geography allows us to take environmental factors like the climate, like weather, like soil geology and vegetation, and overlay them, integrate them with economic factors. Think infrastructure, energy, and water networks, illuminating the connections between these things. And we can take social systems, that's us, population, health, equality. Geography provides the framework for this understanding. Now, if you're a technologist or a data person, you might understand the idea, the power, if you like, of a foreign key, an index field linking two data sets together. Well, this is why I love geography. Geography is the ultimate foreign key. It provides a link between almost every data set. So we can use geography as a mechanism, if you like, for interoperating between these different sciences. And of course, we use this term GIS to describe the actual tools and technology for abstracting geography. And this, I think, is the digital twin that Mark talked about this morning in the opening plenary. And we at ESRI, well, our mission is to empower all of you to do amazing things with geography and GIS. Whether you are solving the biggest challenges in your businesses, the biggest challenges in your local area, or in fact, the biggest challenges in the world. And we do this primarily by creating software, right? And investing in its continuous development and maintenance. So, audience participation time. How many products does ESRI sell? Anyone want to shout out? There's no prizes? What was that? One. I think one is the right answer. We make one product, ArcGIS, the world's most comprehensive geospatial technology platform. Of course, if you look in my ESRI, you might be forgiven for thinking the answer's 5,000. And actually, the user type changes that we discussed this morning in the opening plenary, these are a fundamental part of this idea as ArcGIS, as a single enterprise-ready, scalable platform. The user types provide access to this platform, and access and a license. They provide access to the capabilities. So if the idea of ArcGIS as a single product is a little bit too esoteric for you, then let's consider instead the two implementations of this product. ArcGIS Online, which is our software as a service, and ArcGIS Enterprise, which allows you to deploy this platform on your own infrastructure or in your own cloud subscription. What new releases of capability are coming up in these two components? And let's also consider ArcGIS Pro, which, as you probably know, is one of the principal apps that ESRI builds on top of this platform. You know, when I used to do these kind of roadmap type sessions a few years ago, I always got to announce some new surprise release, like a magician pulling a rabbit out of a hat or something like that. But you know, these days, our release schedule is actually really, really predictable. It's predictable and it's regular. And that's a good thing for us. It allows us to plan. And it's a good thing for you. It allows you to plan how to introduce these new releases of capability into your organization. So there are 2 releases of ArcGIS Enterprise and ArcGIS Pro each year, one in the springtime and one in autumn. And there are 3 releases of ArcGIS Online each year. Nice and simple. So let's take a little bit of a deeper dive into some of the new capabilities that I'm quite excited about in these releases. So in ArcGIS Online, actually already in beta right now, we have in ArcGIS Online custom printing. This allows you to use ArcGIS Online to generate prints containing detailed layouts, organization-specific layouts, for those times when you really, really need a hard copy or a PDF. Experience Builder is getting a new Express mode, providing a simplified workflow for configuring web applications. Last year, we introduced sort of data interoperability-like functionality to ArcGIS Online with data pipelines. Well, in the next release of ArcGIS Online, you'll start to see model builder-like functionality available, allowing you to automate your ArcGIS Online analysis workflows. And finally, of course, we're going to rapidly invest in and deploy the generative AI and geo AI capability that Richard showcased this morning. Generative AI and geo AI are also going to be a major feature of ArcGIS Pro development over the next few releases. For example, we're looking at how to use AI to improve the generation of reality capture products from drone imagery and Earth observation data. Schema reports, actually already available in ArcGIS Pro 3.3. For those of you working with more complex data models, schema reports allow you to edit your fields, your relationship classes, your domains in Excel. Some improvements, actually pretty subtle improvements actually, in our support for the latest OGC standards, again in Pro 3.4, are going to make it easier to use the Ordnance Survey Data Hub APIs. Pro 3.4 should also include some capability to read NoSQL databases as well. And finally, improved visualization effects are going to allow you to bring your 2D and 3D maps and scenes to life in ArcGIS Pro. In ArcGIS Enterprise, we're going to see improved capability to handle ultra-high volume real-time data as the velocity extension, which was previously only available in ArcGIS Online, is coming to Enterprise at the next release. We are finally improving the way that you license ArcGIS Pro from ArcGIS Enterprise, if that's something you do. So you will no longer need the license manager component. You told us that you need much more intelligence when you're managing and administering ArcGIS Enterprise. So we're improving, for example, auditing and logging, knowing exactly who did what and when in your system. Kubernetes was mentioned in the opening plenary this morning, so over the next few releases of Enterprise, you will see Kubernetes become fully feature equivalent with the Windows and Linux deployment options. And finally, there's going to be enhancements in the utility network, which models the connectivity of pipes and fibers and cables directly in ArcGIS. This is going to provide utility companies with even more intelligence about what's happening in their network, both geographic and schematic, in the field and in the office. Now, when I showed this slide earlier on, I expect you're probably thinking, well, he's talking about a GIS. He's talking about overlaying data layers. And of course, I was. But I've deliberately used the word system on this slide. Increasingly, the data that we are overlaying is not simple. It doesn't fall into these traditional neat categories of vector and raster data that we've been using for years. In today's complex world, we need to apply these same geographic and GIS principles to more exotic data types and even to entire systems. Different organizations have their own different views of the world because, of course, you all have, or your organizations all have, your own interests and responsibilities. If you like, these different organizations' digital twins only represent a partial understanding of the world. So if we take something like local resilience partnerships, which are responsible in Scotland for cooperating on multi-agency response in the event of local and regional emergencies. So local resilience partnerships are typically made up of local authorities, emergency services, environmental organizations, and utility companies. Now, they need to understand the world rapidly and take decisions because they're acting in an emergency scenario. And they can use these geographic principles that I've talked about. They can use this foreign key index to overlay the different systems that they use, the environmental, the economic, and the social systems, to gain a better understanding of the world. So let's take a look at what that looks like. Let's take a look at an example of the problems in multi-agency response, and then how we can use this geographic understanding to do things a little bit better. Helena.
Thank you, Adam. Data silos can cause a myriad of problems ranging from inconsistent data and collaboration issues to missed opportunities. This is particularly prominent in critical national infrastructure, also known as C&I. And this is due to this sector being made up of multiple different companies, all who format their data in a myriad of ways. So let's consider water and electric companies. For each, they'll have multiple physical assets that make up their distribution network, through which they either deliver water or electricity directly to their customer properties. Due to providing services to many of the same customers, these two utility networks exist in the same locations and at points are even dependent on one another. Additionally, in these locations, there'll be circumstances where both will need to collaborate with the local authority, who is responsible for managing the local transport network as well. However, because these three stakeholders, the electric, the water, and the local authority, struggle to share their data, they're currently unaware of how their networks interact geographically and where their dependencies, or in this case, their vulnerabilities, lie. This means that when issues arise, these stakeholders are often forced to make reactionary decisions instead of informed ones, which, as you're about to see, can lead to a number of issues. So let's look at a crisis event where the local C&I is heavily impacted and the various stakeholders need to collaborate to mitigate the effects of the crisis to reduce the risk not only to customers but also to their networks. So looking at our local area of Fort William, which many of you will have seen in the opening plenary, we currently have an ongoing storm with heavy rains of 150 millimeters and strong winds of 82 miles per hour. So this catastrophic rainfall has caused River Nevis to break its banks and flood the surrounding areas and the properties. In addition to this, severe winds have battered the town and the surrounding tree line. And here at this station, we have reports of an overhead power line that has been downed by a fallen tree due to the winds. Then, if we move over to this pumping station, we're also having reports of low pressure. And this pumping station supplies water to over half of the town. So, as all of this is happening, all of these stakeholders are starting to receive multiple complaints from all of the residents. And each will be responsible to gain an understanding of the impact on their individual networks. And each will have their own way of reporting and formatting their live data, which can lead to difficulty in sharing this, especially during a crisis period with short notice. So let's take a look at what each will be doing in their respective data silos. So we're going to head over and we're going to look at the Fort William Local Authority. So they're responsible for managing the town's flood defenses and mitigating any impact on the local transport network and their residents. So here in their dashboard, we have a map of the town with the colourful markers representing the different neighbourhoods of Fort William. And we also have this purple icon here, which represents a refuge centre that was set up when the storm warnings were issued. However, we can see from a flood polygon here that the flooding has now blocked this main route, which is the A82, and in doing so has cut these two neighbourhoods off from accessing the refuge centre, And this also means in the event of evacuation, these two neighborhoods are cut off from emergency services as well. Now we have our indicator down here, and our metric reads that we have 42 flooded properties, which is setting their metrics quite low. So, whilst the local authority are going to be trying to alleviate this situation for the residents of the town, they won't have any visibility on what the utility companies will be dealing with. So let's head over to our Fort William Electric Company and take a little look. So here we have their operational dashboard that sits on their private server, and it shows the live data from the electric network. So on the map, we have our distribution network, and we have our overhead power lines in orange that you can see running here, and we have our underground power lines that deliver directly to properties in the brown here. And this yellow icon represents that fallen tree on the power line that was connecting to a substation. And in this area with the red is where they've started to receive multiple complaints from customers. And it's important to note that this line, which was impacted, was carrying medium voltage power from the Fort William substation over here to the Pine Grove substation here, which is where that would be then transformed into power that's safe for residential use. So we're going to look at running a utility network trace. So by doing this, we can track the flow of electricity through a network from a starting point, like this Fort William substation here. So let's give that a go. So first, we're going to select our electric trace. Then we're going to add in our point here. And then for the barriers, we're going to add them here. Well, we're going to try that slightly differently this time. So we're going to add in a barrier here where we know that we have had an impact on the network. And we're going to run that again. And this time we can see that this neighborhood is entirely cut off from electricity. So that means that we have 288 customers completely without power. But it's important to note that currently a trace can only be run on the data for the network that you have access to. So in this case, for the electric company, that is the electric network. So they have absolutely no visibility on how this outage is going to be impacting any of those other stakeholders, such as the water company. So let's move over to Fort William Water, where we have their operational dashboard here. So we can see that they've been notified of the low pressure loss, and we can see that they've had numerous complaints and that they've already run a trace and currently have 1,001 customers without water. And as you can see from the red houses indicated here, that's over half of the town. So they think that this pumping station's power supply has been affected by the storm, and they think that's what's causing the outage, but they won't know that for certain, and they won't know when or why or what is going to happen with any repairs. So they've been left in the dark, both figuratively and literally. And with the road blocked in certain areas, their engineers won't be able to get out to the pumping station to do any repairs that they can. So as it stands, there's two neighborhoods which are completely disconnected from accessing the refuge center, one neighborhood without electricity, and we have an entire half of the town with no access to running water. So all of these stakeholders are currently in the dark. We have local authorities scrambling to open roads and support the residents. We have the water company with an outage, but no understanding of why or when it will be fixed. And we have the electric company trying to solve their own issues with no visibility of the extent of the damage and ramifications for the others.
So what Helena's highlighted is the challenge of separate organisations tackling a common crisis without having the full picture. Let's shift our focus, though, and see if we can improve the situation for Fort William and improve its resilience to deal with crises like this for the future. This time, though, we're going to take a more collaborative approach. So I've created a web app that embodies this collaborative spirit and is going to allow me to simulate the storm and model its impacts across the domains of all three organisations. So as a little intro to the app, I've got much of the data here that Helena was using. I've got my substations as the little lightning bolts, my pumping stations as the taps, my neighbourhoods of Fort William represented by the little houses, and then my refuge centre just here with the shield. And then to simulate the storm, I've got my flood here again, and then my area of woodland that was causing issues for the electric network just up here. While it's useful to have all this information in one place, for starters, this app provides more than that. It allows me to model the interdependencies between the electric, water, and transport networks. This means I can accurately simulate how the system as a whole will respond to a crisis like a storm. So, I'll take a look at the electric first and hit simulate to simulate the storm and show you what I mean. So like the Fort William electric silo that Helena showed, I can perform a utility network trace. So the app starts by running a simple trace of the electric network to get customers that have been disconnected by the fallen power line. So that's these properties here in red. So key to how this app works, though, is that it's also looking for points on that electric network that are powering pumping stations for the water network. And when it's found one, like it has here, it then begins a trace of the water network. So the tool has jumped to the water network and performed a trace to find those properties that have had their water supply cut off. So that's these properties here in red. So this electric to water connection is a critical link between the networks that allows me to build up an accurate model of the systems underlying Fort William. Dare I say it, I've got a digital twin. Because I'm modeling real-world interdependencies, I can not only see how a complex system responds to an event like a storm, but crucially, I can dynamically apply some mitigations to see how the situation could be improved. Before I go any further, though, let's just take stock of the impacts of this simulated storm. So, as I've already covered, half the town is without water. A significant number are without electric. And then I've also got, as you can see on the metrics on the right, quite a few flooded properties and 2 neighborhoods here that can't access the refuge center. So let's try and solve this. At the bottom of my sidebar, I've got a couple of mitigations ready to run. One of them, I'll let you guess which one, will add flood defenses to the River Nevis, meaning that it shouldn't burst its banks. The other one will add a generator to the water pump, meaning that in the event the power goes out, it shouldn't lose its ability to support the water network immediately. So, since we've got quite a few flooded properties, I'll try the flood defenses first. So I'll zoom into the flood and just select my flood defenses, and we can see that that's updated the flood extent, meaning that now the A82 is open. And also, these properties here are no longer flooded. So I'll simulate the storm again, and this time we're going to take in the extent of that new flood. Now, a bit of background on what the app's doing. So the vast majority of the utility and transport networks are never actually exposed in the app. So I can't, for example, switch on a layer to view my electric lines. I've got a few points that I'm using for visualization, but by and large, most of the data is staying within the servers of each organization, which is also where my analysis is being performed. So only the data and the results that are essential for all 3 organizations are ever visualized and shared in the app. So it's finished running, and now I seem to have reduced the number of flooded properties. I've opened up routes to the refuge center for all neighborhoods, but from a utilities perspective, things are not looking quite as rosy. So I've still got a lot of people disconnected from electric and half the town disconnected from water. So I'll try the water pump strategy. I'll hit run again and just keep an eye on those metrics on the right. So behind the scenes, this has updated the properties of each of the pumping stations to give them each a top-of-the-range generator, meaning that, as I said before, in the event that the power goes out, they shouldn't lose their ability to support the water network immediately. And I seem to have solved the water issue, but this is only a temporary fix. The pumping station lost power because of a vulnerability in the electric network. Now, because of the data sharing policy that's in place for the app, I can't view all of my electric network, and nor can I edit it. So for this, I'm going to head into UNE, which is a web-based editor for utility networks. So I've got my problem substation here with a single line carrying medium voltage through this area of woodland that was causing issues during the storm. So as this substation is also supporting the water network, I think we need some extra resiliency here. So one thing I can do is to reroute this power line to avoid the woodland. So I'll just draw in a new medium voltage line, and I'll get rid of the old one. And then just make sure that was a valid thing to do. Click Save, and then that should be reflected in the utility network that I'm using in my app. So I can now click Simulate, and this should have reflected that change in the simulation. So I'll go back to my vanilla storm scenario and just run that simulation again. So the app's now going to run and perform that same analysis, this time taking into account the update to the electricity network. And a bit of warning, this is a proof of concept, and I did make it myself, so I may have to do a refresh if this doesn't perform quickly. But it seems like we've solved both the electric and the water issues with a mutually beneficial mitigation. So this truly demonstrates the power of our approach. Our connected digital twin allowed 3 organizations to see the part that they play in a complex system and allowed me to quickly simulate various strategies for improving resiliency in Fort William. Adopting a systems-level approach like this isn't without barriers, though. While technology and geography make this approach viable, it requires collaboration among organizations like those here today. Take climate change or the recent floods we've seen down south. Increasingly, these are highlighting shared issues that cannot be tackled in isolation. Only by coming together and building more complete pictures can we address these challenges more effectively and create sustainable solutions for the future. And with that, I'm going to hand back to Adam, who's going to wrap up this section.
Thank you very much, Matthew, and thank you very much, Helena. So what have we just seen there? We've seen 3 different organizations with 3 different digital twins. We've seen the local authority with their understanding of the transport network and the population centres. We've seen the utility companies, the water network, and separately, the electricity company. Taken in isolation, the entire systems within these organizations only represented a partial understanding of what was happening. We know that we can use geography to overlay these systems to understand the world better. So let's all do that. Let's all go away from here inspired to use geography to understand the world better and perhaps to help fix it. Thank you very much.